In this refresher video, we are going to find the missing angles using trig. So when theta is the thing that's missing, right? When the angle is missing, we call it theta. So I'm going to draw theta. Theta is the Greek letter for an unknown angle. So when theta is the thing that's missing, I use inverse trig to find that missing angle. So just like we would for sides, I'm going to identify each spot, and I've color coded it the same as our refresher video for sides. So you're used to green being opposite, yellow being adjacent, and pink being the hypotenuse. So I'm going to go ahead and start with example 1, and I'm looking at 14 from theta. And I notice that I have to go across my triangle to get there. And we know that when we go across the triangle, it is opposite. So 14 is my opposite side. And 38 is it could only be adjacent or hypotenuse, right? And since it's touching the right angle, I know it cannot be a hypotenuse, which makes it adjacent. So I'm going to highlight that yellow. I think color coding helps simplify these problems, so I encourage you to do it. But if you prefer to just label the sides as I'm doing right now, that would also be just fine. Okay, so we have our opposite side and our adjacent side. And I look at my SOHCAHTOA. It's important to always write this on top of your work as I have right here. And color-coded in the colors that you specifically used. So I have opposite, which is green, and adjacent, which is yellow. And I look at all my ratios, and tan is the ratio that works for me. Now, the thing about missing angles is I'm not going to use regular tan. I'm going to use inverse tan. So how I write that is theta equals inverse tan. So that looks like tan to the power of -1 is what it looks like. And I'm going to put my fraction in here. So my fraction is opposite over adjacent. So 14 goes on top and 38 goes on the bottom. It's really important that we put the fraction in the right order, otherwise we'll get an entirely different number. Okay, so now I'm going to put tan of 14 divided by 38 into my calculator. And I get that theta is equal to 20.22 degrees. So I will write 20.2 degrees. Okay, that is how I did example 1. And I'm just going to do another example to make sure we're all on the same page. Looking at example 2, I see that the 3 is right next to my theta. So when a side is right next to theta, and it is not the hypotenuse, it's called adjacent, so I'm going to highlight it my adjacent color of yellow. And 6, well, it's slanted like a hypotenuse might be, but I don't want you guys to be fooled by that. Again, always refer back to the right angle. The right angle is touching 6, so I have to go across my triangle to get there. And when I go across, we call that opposite. So it looks like I have another tan problem. So I'm going to write theta equals tan, inverse tan, put my fraction, right? And it's always opposite over adjacent. So I'm going to put 6 over 3. So this is how we find missing angles. Now I type this into my calculator. I'm going to type inverse tan of 6 divided by 3, and I get 63.4 degrees. That is my answer. This is how we solve for missing angles.